Hi everyone, welcome back to my channel, and today in this video we are going to study about the multi-leader replication. In the previous videos of this replication chapter, we have covered about what are replication, what are the architecture types, what are the commit types, where we study about the synchronous, asynchronous, semi-synchronous one. We also covered about the leader election. Now we are going to cover the second architecture type, that is multi-leader replication. Okay, so without wasting any time, let's get started. So, what is multi-leader replication? That multiple servers can accept the write and each leader replicates to other leader. So, let's understand it with the diagram first of all. There is one master and master database, and there is one more master database. So suppose what usually happen, let's suppose that this master database is in India and this master database in, let's say, in London. So what is going to happen, the user, okay, will send the request in London. So what is going to happen, it is going to reach to the nearest database. So basically it will reach to the London database, and if there is a user in India, it will send a request to the server and the request will reach to the India database. Now this London database and this India database will communicate with each other with some protocol. We will discuss it, but they are going to communicate with each other. And after this communication, what is going to happen? They are going to store it into the replicas. So London database will have their own replicas. India database will have their own replicas. So these are the master. So what we have studied, that master will handle all the write operation. So India master will handle the India writes, London master will handle the London writes, and they have their own replicas. And when there is going to be coordination, so these replicas will also have the data of London database, and these replicas will also have these replicas, replica 1 and replica 2 will have the also have the data of the India database, because there is a coordination. So they will also have the data of London, they will also have the data of India. So everything will be coordinated. So there is going to be some protocol involved. We are going to study these protocol maybe in the next video in detail, but there is going to be some sort of a coordination where all the data is going to be transferred from one database to the another database and going to be stored into the replicas. This is known as the multi-leader replication. Now let's understand why we use multi-leader replication. First of all, we have studied about that with the help of this multi-leader replication we can increase the speed, because London user can send the data to the London database, India user can send the data to the Indian database. That is the first reason. Secondly, I mentioned some of the reasons here. So first reason is you can see multi-data center, one leader per region, writes are local and fast. We have covered this. Second is offline apps. Your phone is the leader when offline, syncs when back online. So think of it that you are using some kind of a mobile application that works offline. Okay, so what is going to happen whenever whatever the changes that you are going to make, that are going to be stored in your mobile application. So everyone who is using, they are going to have their small master database into their phone, and whenever you got an internet connection, that data is going to be transferred to the replica or to a common database, that we can consider it as a multi-leader replication. Third is collaborative editing like Google Docs, and there can be example of Jira, Notion, okay, anything in which like multiple people can write on a single page, okay, because everyone is going to edit some other database, and like there is going to be collaboration. That's we have studied it here as well, that two masters collaborating. Okay, so you can see that there is an example of Google Docs. So it, now you understand, it becomes very important to understand how this collaboration, how this protocol work, how this database are going to connect with each other. Okay, we are going to study them in our next video in detail, so don't worry about it. Now what are the problems with the multi-leader? Let's see that. There are going to be several problems in multi-leader. So first of all, I want you to remember, I made you study one topic about, like when we were doing this system design topic playlist, we studied about time and clock. I don't know that you remember it or not. I don't know that you've studied it from my video or not, but I want you to know this topic, time and clock. If you know this topic very well, it will be very easy for you to understand the problem of multi-leader. So I'll give you one small example. for example, there are two machines, machine A and machine B. So these are the two separate entities, and they both are working on a different clocks first of all, and they both can have the different time. For example, A clock is working in India. So suppose the first A machine is in India, and B machine maybe is in US. So there is going to be a time difference. There can be a time difference. Plus, for example, that A machine is from some other company and B machine is from some another company. So the clocks that are working inside them can have some physical different logic. Okay, because these are the hardware machines. There can be some different logic. So there can be some time difference in them. When you store the data into the database, A machine can store something else and B can store something else. So there can be an issue. I want you to remember this topic that we have studied in our physical clock, Lamport clock. So you can go to my playlist and study, or otherwise if you want to study from somewhere else, you can study. No worries, just go and study so that you can understand this thing. So now let's get back. So what happens? There is a writing conflict. Two leaders accept different write to the same data at same time. Okay, same time that I mentioned, but now what is going to happen? Like leader A set, let's say, update set username John at time t equals to 10 milliseconds. B also say name equals to Jane at t equals to 11 milliseconds. Now A and B disagrees. Who is winning? So there is leader A and there are leader B. Okay, one is in London, one is in India. They both accept a write on a same row. Now what is going to happen? There is going to be a conflict, because this leader is sending the data to another leader, and this leader B, basically a London master, will also send the data to the Indian master, that this is the row update that we get. But now there is conflict. This is the problem in the our multi-leader replication. We have studied about the problem in the multi-leader replication. Solution is into the next video where we understand this conflict resolution, how this works. Okay, so we'll not go into the solution. We understand what is multi-leader, where we use it, what are the problems. Now we are going to see how to implement it, what are the topologies that we usually use into the production. Okay, so first topology that comes into the multi-leader is all to all. That means, let's suppose that there are going to be n leaders. Okay, so we have taken an example of 3 leaders right now. What is going to happen? Whenever leader A will get a request, it will send the write to the another leader. So the leader A will get the request, it will send the write to the B and leader C. If leader B will get, send it to the A and send it to the C. If C will get, it will send to the B and send it to the A. We haven't studied about the conflicts, so there can be conflicts and we are going to solve them into the next video, so don't worry about it. It is very fault tolerant. Any leader dies, other can still talk to each other. Let's say A dies, B can still talk to C and C can still talk to B, and if A comes up, these both can send to the data to A and C can also send to the data to the A, so that it can again comes into the sync and now they again can talk. Okay, I mentioned the problem here. The same problem, C may get update before create, use version vector to fix. Did you guys remember what is version vectors? We studied about the vector clocks, that these leader B's, like these servers will maintain their own clocks. Okay, so like there are going to be like 3 clocks that they maintain. I don't know that you guys remember it or not. Let's say for example, so there are going to be 3 clocks. If I write, let's say let's for example I will write in something like this. So A, B, C, A comma B comma C. So for example, if B gets some right, so it will be like 0 comma 1 comma 0. Okay, now what is going to happen? If sorry, just a second. This is known as the write of a B. For example, now what is going to happen? This B sends the data to A. How the version vector will look. Okay, so of course A comma B comma C. Okay, so this is the version vector of B. Okay, now let's say I will make the version vector of A. It will look something like this, 0. So now we are going to update the data of A 1 comma 1 comma 0, and C is going to be like, after that C will also get the data and it will going to be A comma B comma C. It is going to be, let's say, 0 comma 1 comma 1. Okay, now C will also send the data to A, or let's say A will send the data to C. Now what is going to happen? Now after that some point of time, this A and C will also become 1 comma 1 comma 1, and this will also become 1 comma 1 comma 1. This will also become 1 comma 1 comma 1. Okay, this is not actually how it works. Study this thing into the vector. I explained the complete algorithm there, but for understanding I've just made this thing. Okay, this is how it works, but like there is some logic, like you use the maximum number, it increases the size, there is some logic, you can go and study there. So we understand this all to all topologies, and we have to do this because we have to maintain the order. Secondly is a star topology. In the star topology, what happened? In this hub, what we can do is we can write some custom code. So what I mean by this custom code, let's say for example, whenever the write is coming to the server, so basically there is a server here, it will send the write to this server, is this hub, or you can say one common service, and this common service will responsible to write it into all the leaders. They have their own separate replicas. Okay, this replica, but this hub will send the write to this leader A, this will send to leader C and leader B. So this is what hub is doing. The point is simple, that if there is going to be a hub, then there is going to be a single point of failure. If this hub down, then everything is going to be down. All coordination through one node, easy to reason about. Yes, I mentioned it here. Single point of failure, hub dies, entire replication stops even if all others are healthy. If this particular thing dies, then there is going to be a problem in the system. So this is known as the topology, star topology. So this is how you achieve this multi-leader replication in it. Third one is, the thing is, if you're using hub, then you will notice that there is going to be less chances of the conflict, because writes are coming and the hub is sending all the write operations to all the leaders. So if there's going to be change operation also, it will come to the hub and then hub will send. Okay, and it will always send the same request to every leader. So there is very less chance of conflict, or there is going to be no conflict, I guess. Now let's going to be topology 3, circular ring topology, in which what is going to happen? Each node gets write from the previous node and pass it to the A and pass it to the next node. So A will pass it to the B, B will pass it to the C, C will pass it to D, and D will pass it to the A. Okay, but the point is that there is not going to be a loop, so don't worry about it. So for example, if the user send the request to leader A, so leader A will pass it to leader B will pass it to leader C, and leader C will pass it to the leader D. And it is going to be a chain. For example, that there is going to be one more user, okay, it send the request to C first directly. Then what is going to happen? C will pass it to the D, D will pass it to the A, and A will pass it to the B. Okay, then B will not pass to the C. I'm telling you that there is not going to be a loop. Let's discuss it, how loop is stopped. So whenever the request come, what is going to happen? We mark it as that this is the node, this is the parent node. So for example, leader C request come to the leader C, so we'll mark it as a parent node, and we know its next node. So leader C next node is D, D next node is going to be A next node is going to be B, and B's next node is going to be C. But we, every time when we send it to the next node, we always check, is it a parent node? If it is not a parent node, we will keep on running the loop, but if we found the parent node again, we stop. So let's say we started from the C, we know that this is the parent node, we'll send to the B, D is not a parent node, D will send to the A, not a parent node, A will send it to the B, not a parent node, B will send it to the C, it is the parent node, so we stop. So from wherever you start, you will not form into a loop. Okay, it will reach, the data will reach to all the nodes, but it will not be continuously keep on passing. So this is how this ring topology works. One node failure can break the whole ring. So what is going to happen? Let's say this leader C fails. Now what is going to happen in that scenario? A will send the data to B, but B cannot send the data to C. Okay, because this is fail. And the problem is that B only knows that it can only knows the destination of the C, because now it is like a linked list. B knows about C, C knows about D. It is a chain. Okay, so this is known as our ring topology. So this is all for this video. In this video, we covered about what is multi-leader, what are the problems with multi-leader, how where we use multi-leader replication. We covered about the topologies. We covered the 4 topics. The only thing left in this particular video is about how we resolve the conflicts of multi-leader replication, that we are going to cover in our next video. And thanks for watching me, and we will meet in our next video, and bye bye.